So here we have part three, where we will divide the CSTR from homework to part C into 15 CSTR in series. So currently there's only one, and we want to split this up into 15 streams. So the first one goes in, the initial stream goes into the first CSTR, then that goes through the second CSTR, then the third, the fourth, fifth, all the way to 15. So here it wants us to divide the volume and the heat transfer, and divide that by that 15 because we have 15 different CSTRs. So this will give us a different reaction rate for each CSTR, and our initial concentration, it says here, is our is 0.5. So this is the initial concentration going into the first CSTR, and then the concentration then going into the second one is the concentration coming out of the previous CSTR. So the concentrations will vary throughout the series. So we're going to go over to the code, and I have here my homework 2 that I had initially worked out in a previous video, where I explained how I got all my equations and stuff. So our equations will remain the same. So this equation is the same for all the CSTRs. Again, the only difference is this concentration. This equation will vary because, again, the volume. So the volume and the heat transfer are being divided by 15. So these equations will vary with that depending on which CSTR is currently being run, or I guess like so like, you know, it's divided by 3 if it's in the third CSTR, and so on and so forth. So to start this, we'll first have to set our variable. We'll have an n equal to 15. So again, this can change depending on how many CSTRs you have. So I will divide the volume by 15, and I will also divide this heat transfer by 15. And we do have to change the time and the initial concentrations. So this will be np.full, and we want to put it in terms of n and 0.5. So then again, this is just changing that concentration from the initials and then all the way to what it is to 15. So this is what this is doing. We'll do the same thing for down here. Oh, and I believe this is actually 350. I think this needs to be changed to 290 if I remember correctly. Let me go check. The coolant temperature is 290 and the initial feed is 350. Okay. Wait, I think I have that backwards. No, that's right. Okay. Then we'll just keep this time at 10. So then we'll go down here and we will go to our first equation. Okay, so here I'm going to split and the temperature. Because throughout the CSTR and in each section, it'll have a different variable for each, or I guess a different number. So we want to, we don't want to set it equal to anything. We want to give it its own variable for each individual CSTR. So to do that, we'll do vec, and then we'll do this one first. So this first one is going to be vec, and this is going to be from the beginning to n, n minus 1, so to 14. That one will be from 15 to the end, which is 30. Equation stays the same. However, now it has its own individual variables for concentration and temperature. So here I'm going to, this is our first CSTR in series, and I'm going to name this first with an O because these are our initial ones. Our initials stay the same, so the initial values, the CA in and T in, stay the same. However, here this gets a 0. This K value. Essentially anything that has to do with variables right here gets a 0 for these set of equations. And remember, these stay the same because each CSTR has the same equation. They'll just have different rate of reactions because each one will have different concentrations and different temperatures. So again, this will be 0. So this will stay the same. This one will be changed to 0. This one will be changed to 0. This K is changed to 0. This concentration is changed to 0. Oh, and this 0 is not actually like turning it into 0. This is just I forget what we call that. Like 0 just relates to the first CSTR in series. And then like I guess key, I'm like blanking on what you call this. And then the 1 would line up with the second CSTR and so on and so forth. So then we, let me make sure I have all those zeros right. Okay. So then I'm going to do the rest of my CSTRs. So I'm just going to say rest of CSTRs in series. And I'm actually going to copy this equation because it's gonna be the same except for the I can't think of the name of the keys, like the zeros. So we will take the knots off of this. So actually here the CA in does change, it goes away. And for this one, since it will be, we're wanting to take what came or like the one that became before it, we want to put it as our initial value because whatever is the of the CSTR, the first CSTR is the input for the second one. The output for the second one is the input for the third one, so forth, so forth. So this one, we actually have our colon and -1 with this one down here. So we're gonna have our -1. And then for these, it'll just be 1 colon. So it'll go from 1 all the way to the end, which actually here would be 14. So we'll do the same thing for this one and all of these. Okay, then next we'll change this. An array, but it is CON, CAT, and then this will become DACO, and DTO, and this is actually P dot R underscore. Underscore, and this will be ECA and DT. Two, those two. Oh, I do not need a parentheses there. There we go. And then we will run this. Perfect. So then actually we are going to come down here. I'm going to this. Down here for our solving this through IVP. I'm going to get rid of this np.r. We do not need that. And then I'm going to put on a parentheses. Also don't need the derivative. Perfect. Okay, I think that's everything for this. Then we'll return this. Oh, I left in the underscore here. Let's try this. And must not contain. Oh, yeah. These have to be the same, not TO. It has to be just, now this is just CA. And then this will be T. Oh, that should make it better, I believe. Okay, there we go, perfect. So then next we will, so here we're gonna start plotting it. So I'm just gonna modify this. It's not gonna be exactly the same just because we do have 15 CSTRs. So this first one, let's say the same. I am gonna add this end time plot. If the time end is 500, we want there to be like one more plot than what the time is because there's one more integer in that. Yeah, so I'm gonna make that 501. So then in this, instead of this being just 500, saying how many plots are, the 0 is from the beginning, time end is to the time end, and this is how many plots we want on the graph. So I'm going to say n time plot. So then we're going to we're going to take out the plots here. Will stay the same. We're going to want to reshape this because we're going to be plotting the concentration. The set up here is from 0 to 14. And down here we said that we went, for the temperature, it was from n to, which is 15, to time to the end, which is 30. So we want to split those into 2. And to do that, we'll reshape this and we'll split it into 2 for our integer n. And we will have n time plots. So then we fig equals make subplots the same. This down here, technically I could do it this same way, but I would have to put in 15 15 of these, each of these lines for just the concentrations, and then 15 exactly like this for the temperatures. Personally, I don't want to do that. Easier way. So to do this, we will just say for I in range n. But this is just basically saying like for this concentration, it'll be this plot and it'll be named this. So it'll be our fig dot scatter. And this will be equal, or not equal, sorry. Sorry, I blanked there. It'll be x equals our time plot, y will be equal to CA brackets I to excuse me, I to colon, and then we will want to name this. So the name, again, so what this is doing right here is I just have to put, and this will just be saying for, again, this concentration, or for this CSTR, we want this plot, and this will be the name of it, and this is just a very generic way of doing this, instead of having to put, this does the work for us, instead of me having to input all of those. So the name will be F C A I, and then row will be equal to 1, column will be equal to 1. And then everything else stays the same. So we will run that. Okay, perfect. So this is just showing us each of the concentrations that are coming into each of the CSTR, or coming out of the CSTRs. Notice that it does start at 0, so there are 15, even though it looks like there's only 14 CSTRs, there are 15 because it starts at 0. So, and this is the plot of that. So now we want to do the one with the temperature. So basically the same thing. I'm actually just going to copy this. I'm going to come down here. Oh, I don't know why it does that now. This updated and I don't like that. So I'm going to control paste this. This is just going to be Fig 2. We're going to change all of these. Oh, I had 2 columns. I think that should only that it really matters, because I didn't, just makes it wider. So I'm going to change that back to 1. This will be changed to temperature, and this will be changed to temperature. And these will show I need to also and then I'll plot. E. Okay. Oh, this fig also has to be, I think everything that's a fig has to be 2. Duh. Okay, let's try that now. Okay, perfect. So here is our concentration graph, showing our concentration over time for each CSTR. And then this is showing each of temperatures of our CSTRs in this was homework 3. Thank you.